Hello friends, last class I discussed about the how can you represent the binary number in the form of the positive and the negative. Okay, so this whatever thing we discussed till now, these are related to binary number only. How can you represent the binary number to other system, and how can you represent the signed binary number, right? So after binary number, another two three numbers are there. Gray number, gray code, binary code, BCD codes are there, right? So gray code, BCD codes, these are associated with the only binary number only, but the application of BCD code and application of the binary, sorry, gray code, these are the different. Okay, for different application we need to use the binary code, gray code, BCD code, and access 3 code. Okay, so first we'll tell about the what is the main difference between binary and the BCD code. Okay, so what is the importance of the BCD code? Why we'll use the BCD rather than the binary? So this we'll discuss. This is associated with the binary number only. Okay, so suppose any kind of binary number consists of 0 and 1. Okay, suppose any kind of the when you have any BCD code is related to decimal, and this is the bridge between decimal and the binary. Okay, so suppose if we have the decimal number 12. Okay, this is the one decimal number, right? So if you want to convert this decimal number into binary, directly you have to divide the 12 by 2. In this way you can convert decimal to binary. This I have already discussed, right? Or you can write any kind of the binary number in 8421 format, weighted code format. Okay, 8421 format. Suppose 8421 format, if you want to write 12 consists of, so from here how can you get the 12? If you add 8 and 4, you will get 12. So below 8 I have to put 1, below 4 I have to put 1. Okay, this is the binary number of 12. Okay, so then when we use the BCD number? BCD number, the full form is the binary coded decimal number. Okay, binary coded decimal number. That means the name is like the binary coded decimal number. So whatever decimal numbers are there, each number can be coded, can be divided, encoded into the binary number, right? So here also the decimal number I am converted into the binary, but there is a little bit different. Okay, so total 12, entire 12 I am converting it into binary, but here binary coded decimal. That means each decimal number, each number, okay, if any number consists of 12, so inside the 12 there are two decimal numbers, right? 1 and 2, right? So you can individually convert it into coded binary number. You can individually, so one can be divided into binary, and 2 also can be divided into binary number. That's why the name is like the binary coded decimal. So whatever numbers are there, suppose 130 or 150, or any kind of the 125. So 125, inside the 125, 1, 2 and 5, three numbers are there, three decimal numbers are there. So each decimal number should be coded into the binary number. Okay, that's why it is like the binary coded decimal. Okay, inside the 125, only entire 125 you can convert into the binary by following the process. Okay, so this is the binary. So normally what is the importance of the BCD number? Okay, first I will tell the BCD number. So each digit in any number, each digit can be represented into the binary number. Suppose 12. Okay, so 12 goes in 10th decimal point it has 1, in unit place it has 2. Okay, 1 and so binary coded decimal. This is also decimal, this is also decimal number. This entire number, the individual number should be coded into the binary. So okay, if I convert a single 1 into the binary, okay, 1 means 0 0 in binary coded decimal. Okay, each digit consists of 4 binary digits. Okay, each digit consists of 4 binary digits. It is called as weighted code. Okay, which consists of 8421 weightage. Okay, so 1 that will be converted into the 0001, and 2, from 2 how will get 0010. This is the 84 to 1 format, right? So BCD number of 12. BCD number of 12 is, if you enter 12 as a BCD number, so you will get a corresponding binary number. This binary number 001, 0012. Okay, normally in computer we used to give the BCD number. Okay, we used to give the BCD number. So the BCD number, that is, suppose if we enter 1 2, so computer will store the binary number of 1 2. Okay, so if we give BCD number, if we give 12 as a decimal number, that will directly convert it into the binary. Here we will get 1100. Right. So suppose sometime, so human will not understand what is the 1100. Okay, so for 12 the human can understand, but for bigger number human will not understand, right? But suppose if we enter the 12 as a BCD number inside the computer will store this number as a binary. Okay, so from this number the human can easily understand that this is the corresponding decimal number of this BCD code is 12. Okay, so suppose you have 178. Okay, so it is very difficult to convert into binary, or it will take lots of time. So if we convert 178 into binary, we will get a 11100, something like that. So from binary, from that particular binary number, you will not understand easily what is the corresponding decimal number, right? So if you give 171 as a BCD number, what is the equivalent BCD number? So 1 means 0001, because each digit consists of 4 binary digits. Each decimal digit consists of 4 binary digits. Okay. 7, if you write in 8421 format, it is like that, 0111. 8 means 1000. So if any BCD number is given, okay, binary coded decimal, all the decimal number is coded into the binary number, binary coded decimal. So from this number you can easily understand this is 1, this is 7, this is 8. So that is the interaction between human and computer. The human can easily understand what the computer is trying to say, okay, which number it is. But if you convert 170 into binary, so we will get such random number 110000. So from this binary number, they will not easily understand what is the corresponding decimal number, right? So another advantage, what is the advantage? So human can easily understand this 178 number, okay, BCD number, okay. So it will take less time to understand the thing, but it will take more time to understand the thing. Disadvantage of BCD number is that it has more, it requires more storage space. Okay, it requires more storage space, because here in this BCD number, suppose if you see 12, so if we store 12 as a binary number, so you will get 114 digits, right? But if you store 12 as a BCD number, you are getting 8 digits. So for storing the digits, so its computer will require more space as compared to the binary number, right? This is the disadvantage. If we see the advantage, so it is easy to understand, easy to compute, okay, for computer also and for a human also. So this is the difference between BCD and the binary number, okay. So for computing purpose, which human can understand, so for this thing binary coded decimal number is mainly required, okay. So if you add a binary coded decimal number, so here you can see, if we add binary coded decimal, the addition of the binary coded decimal number is little bit different from the normal binary addition, right? So this we will tell later, okay. Next is the binary and gray code. Next is the binary and gray code. Okay, before dealing with the binary and gray code, there is one number that is called access 3 code. Okay, uh, this is normally not most applicable, but what do you mean by the access 3? Suppose you have any binary number. Okay, so if you add 3, what is the binary number of 3? Again 0011. Okay, if you add 3 with this corresponding binary number, so you will get a other number, that is the access 3 number. Okay, so 110, so this is suppose binary number, you are adding 3 as a binary uh, given binary number. Okay, so 1101 111 1 carry 10. Okay, so this is your access 3 code for this corresponding binary number. So what you are getting, this is 6. 6 you are getting. That means if you see, this is 3, 3 plus 3, this is 6. This is the access 3 code. This is also used for some computational purpose, or some you can use this kind of the code in communication also. Access 3. Access 3 code means so you in binary number, in any kind of the binary number, if you add 3, okay, 3 means 0011, you will get a another number, that is the access 3 number. Okay, next is the gray code. Next is the gray code. Okay, now binary to gray and gray to binary. Okay, so here it is a binary code. Suppose if you have two inputs, right? If you have two inputs, so how many combinations are there? If you have two inputs, any kind of the any kind of the numerical also, if you have two input in any number, two inputs in the binary digits are there, right? So if two binary digits are there, so 2 is the binary, radix of binary. If two inputs are there, how many combinations are there? 2 to the power n. Here n is equal to 2. So 2 to the power n means 2 to the power 2 means 4 combinations are there. Okay. So here I am writing here. So two inputs are there. 0 0 0 1 1 0 1 1. How will write the 4 combination? So 4 combinations are there. So 4 divided by 2, you will get 2. So the 0 and 1 divided into two parts. 2 0 2 1. And here again this 0 0 divided into two parts. 0 1 and 0 1. In this you will get the 4 combinations for 2 input, right? Now here you can see. So if you go from so this is the 0 corresponding decimal number, this is 1, this is 2, this is 3. Okay, so if you go from this 0 number to 1 number, you can see this number is changed, it remains same, this number is changed. Okay, but here if you go from here to here, you can see this number is also changed, this number is also changed, right? Again if you go from here to here, only single number is changed. In first case and third cases, you can see only single bit is changed, but in the middle case you can see two bits are changed. Okay, if you go from 1 to 2. Okay, in binary number, if you see the decimal corresponding decimal number, so you can see. So if you write a 3 combinations, 0 1 2 3 bit 3 input combinations, you will get the 8 combinations, right? So in this case also you can see, right? So here I am writing A, B, C. So total 8 combinations are there. So total 8 combinations are there. Okay. So now here you can see these two bits are remain same. This is changed. Here also you can see this is remain same, but these two bits are changed. Here also only one change, right? Again here you can see these two bits are changed. 3 bits are changed here, right? But if you go from one number to another number, there should be a 1 bit change. That is called the gray code. Okay, I am telling here. This is the binary number. Binary number means the number starts from here 0 to 7. All the decimal numbers converted into the binary number, right? Here also 0 to 3, all the decimal numbers converted into the binary number. Okay. Now here, what is the now here? This is the binary number. Now here I am writing gray number. Okay. What is the gray code? So for 00 you will get a same gray code. For 01 also you will get same gray code. But in the middle case you can see 2 bits are changed. But for this case after 01 you should have a such a number. In this number there should be a 1 bit change. Okay, so you have to write 1 1. Okay, so that means it is remain same, it is changed only. Okay, in this case you can see 2 bits are changed. 0 to 1, here 1 to 0. But in gray code combination, if you go from one number to another number, so there should be only 1 bit change. After 1 1 you can write 1 0. You can see now this is remain same, this is changed. Okay, see, so this is the gray number. So 00 is the gray code for corresponding 00. So 01 is also gray code for corresponding 01. But 1 is the gray code for corresponding binary code of 10, right? 10 is the gray code for 1 combination. Here you can see if you write the gray code here, 000 same, 001 same. Here you will see that, here you can see 011, right? So this is only changed. Now here you can see 010. This is remain same. Okay. Now here you can see, now it will come 1. If you write 100, it is changed. 2 bits are changed, right? So it will be like that 0 1 0 1 1 0. It will be like that 1 1 0. Okay. Next you can see that it will be like that 0 1 1 1, right? 1 1 1. So in this way you have to write, but it will be difficult to write the corresponding. So if you see, so in this case only 1 bit is changed, in this case only 1 bit is changed, right? But for all the cases it is difficult to write after 1 1 which number I have to write. Okay, so that only 1 bit is changed. Okay, so there is a one process how can you convert the binary number to the gray number, corresponding gray number. Okay, but before telling to conversion I have to tell what is the use of the gray code. So what is the use of the gray code? Gray code mainly used for error detection purpose in communication system. Suppose in communication system if you are sending any binary number in the form of the information, okay, so at the other side you will get some error in the binary, in the that input information, okay, due to the noise. So if you have some numbers, to detect the error, which number is error, error is inside which number, so by doing the gray code, by using the gray code you can easily check. Oh, so suppose this, so then by default due to the noise the 110 is changed to 111. Okay, so now we can easily check error, so only this bit is changed. Okay, so there is, so it is mainly used for error detection purpose in communication. Now here I will tell how the gray code we will get from the binary code. So from the truth table I have to write one by one. It will take lots of time. After 1 1 on which number will appear, so that 1 bit is changed, right? It is little bit difficult and time taking. So there is one procedure. Okay, suppose B2, B1, B0. This is the corresponding binary number. It is B2, B1, B0. Okay. Suppose I am taking this one 0, 1, 0. Okay. So what I have to do for getting the corresponding gray code? As a G3, G2, G2, G1, G0. Okay. So this bit will be remain same. Okay. The second G1 bit, how will get G1 bit? XOR operation between this and this. Okay, XOR operation between 0 0. XOR means suppose you have truth table. Okay, for 2 inputs. Okay, what will be the output for XOR? XOR means it is one kind of the gate that will turn on next class. XOR means it is one kind of the gate. Okay, It is one kind of the gate or system. If you give some input, you will get output. How will get output? If two bits remain same, so output will be 0. If two bits are different, output will be 1. This is the XOR operation. If two bits remain same, output will be 0. If two bits are different, output will be 1. Okay, so if you do the XOR operation between this bit and B2 and B1, okay, here we will get 1. Okay, again if you do the XOR operation between B1 and B0, you will get 1. Okay, so for corresponding 0 1 0, you are getting 0 1 1 as a gray number. See here, for 0 1 0, you are getting 0 1 1 as a gray number. So again I am repeating, B2 will be remain same as a G2. For G1, the XOR operation between B2 and B1. For G0, XOR operation between B1 and B0. Okay, now gray to binary conversion. Suppose you have gray code. It is same gray code you have 0 1 1. So how will get binary number? Okay, B2, B1, B0. How will get the G2, that will be remain same as the B2. Okay, the B2 and G2 both are same, so same 0 will appear here. Now for B1, so the XOR operation between these two bits, that is B2 and G1. Okay, so two bits are different, output will be 1. Again XOR operation between these two bits. These two bits are remain same, output will be 0. Okay, now you can see for corresponding gray code, this is the binary code. So if it is 0 1 1, binary code will be 0 1 0. So the B2 will be remain same as G2. For getting B1, 0 XOR operation between B2 and G1. For B0, XOR operation between B1 and G0. Okay, so in this way you can convert binary number into the gray number or gray number into the binary number. Okay, next class I will discuss about the basic gates and the universal gates and some properties of the gates. So please like, share and subscribe my channel. Thank you.